Thank you, David. All right, so who has actually read the assignment so far, if anyone? Oh, nice. I see a few hands. That's good. Hopefully you understood it. I'll go over it again because it might be a bit vague. But essentially, the idea of this assignment is to introduce a business case and put a project around it. And the reason for that is that most of data science comes together with the business acumen, and it's some sort of a project or deliverable for the management or some kind of executive. In this case, the company that we chose is a hypothetical one. It's an international company that focuses on creating a language curriculum, and specifically for learning English. And to do that, they every year select a bunch of texts, which they put into different grade levels, depending on your proficiency in English. And they want to use NLP, or natural language processing, to speed up that selection of texts. And what you're asked to do is to create an NLP model that can classify texts by their readability and assign them a certain readability score to then allocate to a necessary grade boundary, or to the necessary skill level. The assignment is structured in 4 sections. There's a section where you need to submit a machine learning model to the Kaggle competition, which is then followed by a technical report of what your model does, what is in your notebook, probably some commented code. This is then followed by a scraping section where you go into the Gutenberg website and scrape some books from there to get your own data set. And the whole project is wrapped up by a presentation and a report where you have an executive summary of what you have done, the description of what you have completed in a simpler language, not so technical, and a list of recommendations that you deduced from the section 3 where you scraped stuff. So let's start with the Kaggle section. We used a existing competition, and we sort of put the case around it. And the competition focuses on it's a common link competition that focuses on predicting readability of texts, and that's exactly what we want you to do in the further sections, so you don't have to redo your model or readjust it for the final report. Essentially, you'll be asked to use the training data set. Hello. Should have probably signed in ahead of time. Yeah, I got it. All right. Sorry about that. This is not going great, is it? I don't think I remember my password. Do you want to? I kind of auto-completed every time.
Maybe you can introduce what Kaggle is, and I'll...
Oh yeah, essentially, so in terms of what Kaggle is, has anyone used Kaggle before? Awesome. So it's really a system for other data scientists to compete in projects which are created by real companies, and it's essentially a host for competition. So this particular competition is hosted by CommonLit. They offer a prize pool for the winners, and if your score is one of the top scores, they'll ask you to show them your notebook, see whether they can use that model in the future, and if that's so, they'll award you a prize. And yeah, that's really all Kaggle is, which is a very cool tool. It's quite new, I think, right? It's about maybe 5 years old. Ish. Oh, I don't think it's. Oh. Okay. Okay, awesome. I think it's good. Thank you. All right, so in terms of the competition itself, in the data section, there is a sample submission, a test CSV, and a train CSV. I hope you can see it from the back. And essentially, you'll be using the training data set. You'll be using those excerpts section, which are essentially chunks of text from novels or Wikipedia articles, and they would each have a target score and a standard error. In this case, the target is essentially a readability score, which was deduced by a very long process which they used previously before machine learning was available to them, where they send pairs of texts to students and teachers and let them read it and rank it, and then they combine all of the data that they collected and use a certain algorithm to create that target value. And the standard error is what comes with that target value. Essentially, your task would be to use that training data set, train your model using the excerpt, and then predict the test data set using your model and create the submission in this form. I've made a submission example, which you can access by clicking the link in here. This link in the assignment description, and it shows you how to read the data from the competition and how to create a submission. The reason why I've created this is because for this particular competition, the people who run it, they were concerned about the violations of the rules, and the only way you can make submission is by creating a submission within the Kaggle. So you have to put your notebook on Kaggle and run it on Kaggle, and once you complete it and you need to finish your MSA part of the project, you can just download the notebook and rerun it on your computer locally. So in terms of how to create a notebook on Kaggle, you would go on this website with the Common Readability Prize competition, create a new notebook, name it whatever the appropriate name is. You would also have to turn off the internet on this one. It just doesn't let it go on other websites and find the correct answers to the questions. And once that's all done, you can just copy paste this, for example, put it in, and you'll be able to run the notebook. All right. So once that's ready, you'll be able to download the notebook, create a technical report on what you have completed, how the model runs, and so on. And later, I'll let James introduce the scraping section. All right. So is there any questions about the way assignment is structured, what is expected, and what we're looking for? Cool. So in general, just to recap, in the final presentation, we'll be looking for whether somebody outside who doesn't really know technical terms will be able to understand what the model is about and how it could be applied. And in your notebooks and your technical section, we'll be looking at maintainability of the model and the ability of other people to pick it up and being able to improve it or add some features to it. All right, so once again, is there any questions in that section? No. Cool. Now, I'll let you introduce the scraping part.
Yep.
Thank you.
Thank you, Peter. Just before we start, just a quick show of hands. Have everyone got your Python on your laptop? If you haven't, show up your hand. If you have, you don't. Okay, nice. So everyone got Python on your computer, that's right? Okay, just let me connect it to the screen, and I don't know how to. Hopefully that's that. And it's not working. That's my laptop, and that's my laptop. And just give you a heads up. So basically, this part will be the third part, script something from some other websites. So basically, web scraper is like a kind of get data. So for example, you want to get some movies from other websites, you will need a scraper because there's thousands of movies or like millions of movies. You don't want to like hand click it to like open in new tab. You kind of want like an automated thing to do it for you. So that's why web crawler is there. So if you go to the, what is it called, the repo, just a double, okay? Wait, what? Record it. Oh, okay, I'll have to go closer to the Mac. Okay, so just another hands up. So have everyone got to this page so far or not? If not, just show up your hand. Don't be afraid. Okay, so you haven't. So just go to the assignment page. So if you go through GitHub, and there should be like, give me a second. I'm using a quick way. So everyone know this page, right? The assignment page. Yes, that's yes. And if you go down here, the data science stream, and there should be, oh, that's the assignment. Sorry, my bad. It's in up there. So the code sample and documentation is in the data science one. If you just click into it, it should be there. Is that fine? Okay, nice. So my part will just be the first part, data extraction, basically a web crawler. So I'm gonna do a live code example with you guys. So if you guys just gonna click into that folder, just read me, just be with me. So basically, you can have a quick read through of the README. You don't have to read through all of them right now. Just go to step by steps. So firstly, we need Python, of course. So everyone got Python here. And then next will be the pip thing. So basically those packages. So have everyone got pip, the PIP thing on the laptop or not? So if you haven't, just throw up your hands. So and MSP will help you. Not? Okay. So assume you don't have those beautiful soup stuff. I'll just do an example of you guys. So if you can open your terminal or PowerShell, or on MacBook is called terminal, on Windows is CMD or PowerShell. Have everyone opened this one? Doesn't matter, the format doesn't look the same because I use a customized one. So everyone at this step, right? So just to double check if you haven't got pip there, just enter PIP. Is that good enough? It's PIP. Yeah. If you go that, it should give you something like that, some crappy stuff. Is that all good? It means pip is installed on your laptop, so that should be fine. And right now, what you want to do is just pip install, just copy and paste those codes, because that's what I did. Nah, just kidding. So if you go for pip install beautiful soup, so that's all the soup thing. If you hit enter, it should be installed a lot of stuff. Not really. No. Is everyone in that step right now? Yes, yes. If you haven't, just show up your hand. Doesn't matter. Okay. And now let's just continue. Pip install requests QUESTS. Just step by step. So request is basically request stuff from the internet, and pip install pandas. So pandas is a powerful tool that you can kind of adjust the visualization stuff. We're gonna use that for like convert it to the CSV documents. So have everyone installed those 3 packages already? Yes, yes, yes. Okay, so basically for this workshop, we're just gonna focus on the IMDb database. So basically the movie reviews. Our whole goal of this workshop example on this part is just to get the top 100 movies reviews into our database. The reviews could be just one single review or any kind of reviews you want. So it's just this part. So just top 100 movies. So if you click this link, you will see something like IMDb. That's what does it stand for? International Movie Database or something like that. So basically about movies. So how are we gonna get those data is one of the important things. So the thing is like we have to know the URL. Let me just go up. So URL stands for universal something. I can't remember the thing, but that's basically the top link over here. So that's what we call URL. So basically what we want to do is kind of like, firstly, we want to see how the structure of the movie database looks like. So if we go to we want to search on anything, I'll just show you guys an example. So let's see, how this movie how. Okay, Loki. If you just enter the Loki here, you guys can see the top over here. It says find Q equal to Loki and refer something. That's basically how the URL is structured for this particular website. So in our example, we're just gonna use the advanced search one. Not here. It's basically over here, the advanced search. So that's a super powerful tool, just like a Google search. Normally Google search you just search, but there's advanced search part. And in this case, we're just gonna search by title. Because what's so cool about it is that it actually customizes top 100 for you. So you don't have to worry about what is top 100 or something. So if we go back to the README and look at it again, so you're gonna see similar stuff, but with different, I would say, ticks. So that's one over there on the screenshot. It's like a featured film, and those one is top 100. So I just follow the README, or if you don't want to, it doesn't really matter. So if I do featured film, that will include all the films and exclude all the non-film one. And IMDb top 100, that's top 100. And you don't have to touch anything like that. And then just go to the down. I just want to change it to 100 per page, because essentially what we're gonna crawl is the web page, it's the HTML page. So we're gonna show top 100 on that page. And I will just sort it by user reading. Just let me double check, ascending or descending, because it's gonna change a lot. So descending, basically from top to bottom. So is everyone with this step yet or not? If not, just drop your hand again. Doesn't really matter. Nice. So once you click search, you're gonna see something similar to this. It's like that. Top one is the thing I can't pronounce, the Shawshank Redemption. It's really hard. But the second one, Godfather. Is there everyone at this step? Yes? No? Yes? Yes. Okay. So let's carry on with the README. So basically, as you can see on the top over here, there's a lot of the URL. Just in case, I will show much clearly. So basically, the first one, HTTP, you don't have to know that. And imdb.com, basically the base domain. And search means it's gonna search something. And what is gonna search? Search by title. So title, the question mark, title type. So the type of this title is basically the featured film. And the group is a top 100, as we mentioned before, like a top 100 in the stuff. So it's the top 100 thing. So if you click anything else, it will kind of reflect on. It will kind of reflect on your URL here. So what we also did is like sorting by user rated descending. So it's all showed on the URL. So that's the essential stuff for the web crawling. Is everyone okay with that? Nice. So let's carry on with the maker request. So now let's actually go into coding, not just explaining the concept. So if you can all go to any of the folders and create, just let me zoom in. Doesn't allow me to zoom in, sorry. Just create a new thing and name it whatever .python. So in this case, I'll just go for test.python. That's my personal cell. So if you click Python, and it doesn't really matter which thing you open with, but in this case, we're just gonna open that with Visual Studio Code. So Visual Studio Code is not on here. You can open that with Notepad if you want, but personally, I prefer the Visual Studio Code. Give me a second to sort out the stuff. So is everyone okay with that? Just blah, blah, blah. Import stuff. Has everyone created a Python document and opened that on your laptop? I mean, VS Code? Yes? If you haven't, just show up your hand. It should be, doesn't matter. Okay, that's nice. So back to our README. So make a request. It means we want to use our code to request to the URL we had before. So instead of open the URL on our browser, we want to kind of open that on the code, on the Python, with the Python code. So what we need to is firstly import the library, actually import the request. So just copy right now. So it basically means like we installed the request before, and now we want to import that to our code. So nextly, what we're going to do is like from BS4 import Beautiful Soup. It's similarly, we want to use this library. So copy and paste like that. And import regular expression. I don't think we actually use regular expression. I just put it there just in case, because a lot of like analyzing the URL need those regular expressions to identify those certain structures. But it's not used in this example, so you don't have to worry about it. And nextly is the pandas, basically a powerful machine learning thing. Just copy all those stuff, and you should be all right for now. So if you want to double check if you haven't got those library yet or not, just try to run it. In my computer, it's Control Alt N. It will just automatically run it for me, and it's nothing show up. It means everything is okay. There's no errors. So it's everything with me right now. So basically, we're just importing the libraries right now. It doesn't actually code anything. So that's all right. Okay, no one got any questions? So let's go next. So basically, the URL we kind of targeting is the one we said before. So the featured film, top 100, and sort by the user rating descending. So now we would just want to target URL, and as the next line. So that's the line, and you can see the URL is exactly the same as we had before. If you're not, just ping me out. And response is basically like, sorry. So now we got our URL, and we kind of want to request the URL, right? So with coding, basically it's the request library we got before. So what we do is just request.get URL. So if anyone here is familiar with those web API thing, you will be like get post or something, but it doesn't matter. Right now we just need to get the URL. So get the content from that URL and make sure there's a variable called response is response, basically like that. And then next we're gonna go for this code. It's basically saying we're gonna use the package called Beautiful Soup. So that basically is a super powerful tool that used in the web crawling. It basically can do anything for you in the crawling part. It can get you a HTML document out of it. It can analyze it. It's just a lot of stuff. You will see it later. And if you got any concern with those, like how to use the .something function, there's also a documentation at the very end of this README. You can check it later, but not for now. So right now, if you just copy that code over there, it's basically saying the movie soup. We create a new a new object called movie soup, and that thing is from the Beautiful Soup, the function, or the package. And what the parameter is basically the response.text. So response.text is the HTML page that we get from the requested URL. The HTML parser just basically means it's going to pass the text to HTML. So let me see the next step. So now if you just go for print the movie soup, so basically the response we get. And now if you run it, but anyways, you should see a bunch of stuff over here. In my point of view, it's just a lot of stuff. It got some errors. Apparently, I don't know why. Test.py, inline code encoding error. Character B. That's not right. Sorry about it. Just try to. Okay. Did anyone got ahead of me or something? Never mind. Just let me double check. Okay, I'll go for the old way. So Python python test.py. That should be fine. If it's not fine, then yeah, that's what it should look like. So basically, a lot of random stuff, that's basically just the HTML page, this page, what we get. So if you press F12, or if you like right-click it and with inspect, you will see a lot of elements over there. So that's basically the HTML on this page. Is that clear? So if we just print the stuff, it's basically the exact same thing, but with shorter content. Is everyone with me for this step? We got all those stuff over there. Slow down a little bit. Okay, I will slow down. Okay. So if you got any question, just show up your hand. Okay. So now we got all the HTML things from that URL. Now what we do is, okay, am I too fast or not? Okay with that? Okay. If now we got everything there, we just wanna, okay, I'll just Q&A section. Okay. Can anyone help with this bit of a goal? Or just speak up if you got any questions. Okay, I'll go there. So if you don't have any questions, feel free to just continue reading on the README. I'll be back later. Hey guys, we're back. So hopefully with all the help, you should all at this step or very close to this step. So right now we just print all the HTML here. That's okay. So what's gonna go next is our step 2, which basically to get the individual movie. So for example, right now, here we got this thing like we wanna get the second movie, not the first as example. So the second movie, The Godfather. So if you wanna get a movie link with the pure HTML, what we're gonna do is just firstly to kind of inspect the elements on that HTML page. So if everyone can just open the inspect inspect window. So what you do is just right-click here, right-click on the page, and the last one should be inspect. So or either press F12. Is everyone with me at this step? So you can see all the plain HTML on the right and the actual page on the left. So now if you click the top thing over here, the little thing on the top left corner, so it will let you to see kind of analyze the page. So you can see all those corner squares. So basically HTML is just squares and squares and squares and rectangles. So if you want to locate it to the second one, to the second movies, The Godfather, if you click on it, you can see on the right it changed to the what is called, it's a A tag. Basically it means a link. So you can see the URL, the hyper references here. So it means once you click on this thing, it's gonna redirect you to this link. Which if you click here, it's essentially doing the same thing. It's gonna redirect you to this page, the Godfather page. So now on step 2, what we're trying to do is to actually get this link from our Python code. So if we're gonna go back to our terminal, now go back to our coding part, and just click into the README, and there's all the code over there. I'm gonna go through one by one with you. So basically the first one, movie tag, it means in the movie soups. So right now here, the movie soup, we got all the HTML plain content over there. And for the movie tag, we wanna get the movie tag over here. So basically the A tag, the link tag. So essentially what we wanna do is to get a link on the particular movie. So now if we don't need this print part because it's just showing the result, we can just delete the print part right now, and we're just gonna copy this code. So this code is getting the tags, finding all the stuff. So find all in this movie soups. So find out what we're finding right now is a tag with A, and the attribute with literally no classes. So that's one step. And the next step will be basically because right now we got all the tags with A, but we kind of want to more narrow it down. This one basically means we want to narrow it down to a link that has a hyperlink href that start with attribute with title and end with nothing. So this one here might be much clearer. Is that clearer? Oh, a bit much. Oh my gosh. Is that okay for all of you guys? Okay. So if we analyze line by line, this one basically means now, okay, so previously on line 12, we got movie tags with all the attributes like tag A. Now we want to narrow it down to with the A tag that has a href. Basically, I will show you guys. It's over here. I don't think it allows me to zoom in. No, it doesn't allow me to zoom in. So if you want to look closely to this thing, it's I don't know how to zoom in. Can you zoom in? Yes, you can zoom in. Why? So if we look closely to here, it's gonna be like this tag only has a href, or this is called a field, and with nothing, with no classes. If you see the top one, his parent says there's a class over there. So basically on the coding part, what we want to reflect is that it has no class, and on the second one we want to see it start with a title and end with nothing. I mean, is that clear, or is it not? Is everything okay? Okay. So now we're gonna do, after we find everything on the movie tags, we want to actually get those movies. So this step basically means we're gonna make those. This step is just removing duplicates. So there might be some duplicates, but in this case it's not. I just added there just in case in your future things, maybe in your assignment there might be some duplicates. So that's basically how you remove duplicates. That's only one option. Just list it. I mean, just put it into a dictionary and list it. You don't have to understand this particular line for now. I should put it optional there. And now, we cannot get the movie tags here. We kind of want to show, we just in this particular step, we kind of want to see all those movies. So if you just want to check your result, you can just copy those stuff. Basically, just means like, give me the result on terminals. In total, we got how many movies and displaying the first tile, and this one just displaying the first one. So now if we're gonna run it, oh no, sorry, I should remember this one doesn't allow me to run. Oh, this one actually ran it for me. So if you guys all on this page right now and just run it, you should see something similar to this on the results. So you will get a list of the links. Does everyone got this thing on your terminal? If not, please raise your hand. We're gonna help you. Okay. Or everyone just lost in the previous steps. Okay, no one's responding. It means good. Have we got it? Nice. So now we got all the movie titles. So basically means we can get those, copy this link to the, what is it called? I think it's basically the same stuff as this. So that's the Godfather one, and the first one we copy should be the first in the link. So it's title. Shouldn't matter, right? Yeah. So that's basically we get all the links from the page, and the one I just showed is just the top 10. That's the step 2 we're heading to, and the step 3, as you can see here, the output should looks like that. And the third one is actually to get those movie links, get the review links. So if we go to, I'm not going to go for the first one, I'm going to go to the second one. So now if we analyze the new page we got, I'm going to zoom out a little bit. So you can see here there's a user review. That's the ultimate goal we're going to get. We want to see all the reviews in all the top 100 movies. So basically, with that link, we're going to have all those reviews. As you can see, there's thousands of hundreds of reviews in that particular movie. So similarly, what we're going to do is kind of inspect the elements. Oh, sorry, that's F11. We want to do is F12 or inspect. We want to see this HTML page again and to see how we're going to get this link. Just give me a second. Zoom out. We just want to see how we can get this link, the user review link, in the code. It should be similar to what I just said before. It's again a tag, basically a link tag, and has the hyperreference, and that's another link directed to within that movie. So if we go to step 3 on the GitHub README, it should be something similar. So the base URL, okay. So in that part, it might be a little bit different because in this IMDb system, this link is redirecting to the IMDb title something / review, and we already got the title before, so it should be similar stuff. And now if you got those link, so the base URL is just a base URL. It's a IMDb base URL, the URL, what it stands for. And the movie link we want to get, it has a structure of that base URL plus a tag. The tag basically means the title thing we had before, and the review is basically the review we're gonna get. So if we're just gonna copy those two lines into our codings, it should. Oh, by the way, supposedly you should comment all those two parts. It's just a result. It just like kind of debugging, kind of showing the steps. It doesn't. I mean, in the final product, you should comment it out. You should delete those print stuff. It shouldn't exist on your computer. So the base URL, we got the base URL, and next we want to get all the movie links. So this is actually a shortened form of a for loop. So as you can see here at the back, it's basically doing a for loop, for tag in movie tags. Where's movie tags? Movie tags is the tag we had before. And now what we're gonna have is having a list that contains all the URL in this structure, basically in this kind of structure. Has a base URL, it has a tag, and it has a review. Adding a review on it. So is everyone following on this page? Okay, that's all right. And now we can just print it out to see what happens. And if I don't want to run it again, the output is basically gonna be like this. So it's showing all the reviews link rather than the title link. And just for the correctness, I'll just run here, and supposedly it should work. Is there everyone on this step? Like getting 200 movie reviews, user reviews? Everyone's okay with that? Okay. We're just heading to the next file. If you got any question, just feel free to show up your hands. Should be fine. Okay, you got any questions? Peter, go for it. Should I pause? Nah. So if you got this file, you can just literally click into it, and you can see the reviews. And that's the top one link. And if you go down over there, that should be the top, the Godfather one, the second one. And that's all the stuff. That for now, just retrieving the links. Okay. I'll just give them a few minutes. And if you're wondering what's next, you can always go back to the README. And right now we're at the end of step 3. We're gonna go into step 4 very, very soon. Is that clear enough? That should be clear enough. Yeah. Again, if you got any question, just feel free to raise up your hand. Nice. We're continuing. So, just a heads up from the last conversation, we probably need to remove the duplicates on this step, the movie tags, or not. I don't know. Because for some more people, they get like 200 reviews. That might be you. But anyways, let's keep going. We kind of finished step 3, but just a heads up for the step 3. We're not actually retrieving anything in this step. We're just adding the reviews because we've actually found a common thing on this website. So if we go back to the reviews part, we cannot see in this link, it just reviews. It has nothing specific to do with the URL or something. It's just adding a review after that URL. So you could be like go to this page again and try to retrieve this A tag and with some specific things. But in this example, what we're gonna do is it's just gonna be adding a simple review after the URL. So is that clear or not? Okay. Now let's go to the next step to actually get those individual review links. So if we open the reviews over here, you guys gonna see like something like that. It's gonna be a whole bunch of review lists, So what we're actually trying to get is trying to get this single link. So we kind of want to go to this link and to get the content in that link. So this part is going to be slightly different from what we had before, because right now we actually want those RW something something number. And if you go to the next review, it's going to change. It's not going to be RW 4 something. It's going to be RW 40 something. So it's going to be different for each different reviews. And that's actually going to get a little bit harder, but it should be in the reasonable amount. So now if you go back to our README and go to step 4, it's saying we're going to create a new function called getReviews. So in that function, it's just basically helping you to get review links. Because if you go back to this page, it's a little bit condensed, it's concentrated to one line. You can kind of expand it. You can read it from the last part. For link in movie links, it's basically a for loop. It's checking the thing is movie links. You want to get the links. It's the review links we had before. So if you wonder where's the review links, it's just over here, the movie links. So that's the base URL, just a review of that, whole review list of that particular movie. So now if we go back to step 4, we can see it's a for loop. And now what we're trying to do is actually trying to get a request from Beautiful Soup again. So that's why it says it might take a while. It might take a while because it's getting all those links. So for example, I think we have 100 links already. So instead of initially we're sending Beautiful Soup for 1, we're actually requesting like 200 links with those requests. So it's gonna take quite a while. And you guys gonna see it very soon. But right now, I'm just gonna continue with the code. So the second line, movie review list, is basically just getting the list of those reviews from where we got the review soups. So again, you can see it's a kind of list comprehension. So it basically condenses the for loop into one line. You can kind of expand it to like 4 movie review soup in the soups and column and do a tab thing and get reviews and return something. But this one is more like a shortcut. So what this line is saying in this particular soups in this list, the previous one, we kind of want to identify the one soup. So it basically means the one review link, and we kind of want to get those reviews. So if we go into this particular function, the helper function, it's basically saying, firstly, we got a soup as a parameter, and secondly, we want to find all those links, all those tags with a specific format, I would say. It's an A tag, and it has a class with title. So that's basically things over here. Sorry, wrong one. Let me see. It's F12. You can also click F12. So if you go here, you'll see this A tag has some specific format. It says there's a link, hypertext reference, and a class called title. So in our code, we kind of want to reflect on it. So it's saying find all tag that has an A tag, and the attributes has a class of title. So next, we kind of want to get how many reviews we want to get. We can get 2 reviews, we can get 3 reviews, we can get all of the reviews. But in this example, what I'm doing here is just getting the very first review of this review list. So it's basically just getting this link. I guess in your assignment, you can do whatever you want. You can get kind of last chapter or first chapter based on the particular format in the book Britanburg or something. But in this movie review example, we're just getting the first review link of the first page, I would say, of the movie page. And the next one, it's just review link. It's just generating those review link. So now we got the base URL, the IMDb, and basically here just adding those tags with the referencing. I'm just going to show you how it looks like. So if you see the referencing here, this one, don't know if it's clearly, you can see the URL www.imdb.com/review/ the actual review, the number stuff. So in the coding part, it's just saying, okay, here's a base URL and the review tag. It's just gonna be this particular thing, the review/RW something. Is that clear? Everyone with me in this step? So we're just getting the review function. And here, once we got the review, we're going to put that into a list. As you can see, the specific square bracket is stand for list in Python. And next, we're going to just test our result with print. So if I go back to my coding part, that's still in my previous. Remember to comment out all those stuff. Otherwise, you're going to get a lot of stuff in your terminals. So I'm just going to copy. I'm not going to type every single thing because it's going to waste a lot of time. But try not to copy in your actual assignment because it's bad. You don't actually understand it. And now, supposedly, if I run it with some command, it should be able to give me a list of something. Because as I said in the coding part, it says this might takes a while. So if you want to actually know why it takes a while, you can actually try to debugging it with like print functions in the for loop. But essentially, why it's taking ages is because this request thing, request get link. So basically, if you want to request something, it's gonna take like 1 second. It's not really slow, but if you're gonna have like 100 links already, and you're gonna get 100 links over and over again, it's at least gonna take 100 seconds. And as you can see here, still haven't run anything because it's still running, stuck in this part. So I guess in your actual assignment, it should be all good because it's in a book format, and just this part you're gonna like try to pay attention because it might take a while. And hopefully it should be taking something. And while it's loading, I'll just get you guys to see what the actual output looks like. The output still will be some links, but instead of those movie links, it's going to be more specific. So it go into details into which movie it is and which link it is. So you can see here the movie is the top one, and the link, the reviews, is just the first review we have. So it's just literally go into the top 100 and go into the first one and click into the reviews. Still not showing up. Use the reviews and click into the first link. It's actually the same stuff. So that's one way this is the way we get in browsers, and that one is just the way we get in the thing. It's still not loaded. Is everything all good on that step? Is everyone running that particular code and still waiting for the responses? Right? Yeah. If you got any question, just feel free to ask anyone for the help. Ask our MSP for the help. They're just around there. Someone take one. Okay, your window is over there. And hopefully, still taking ages. Oh, did I already got it? I don't have it. Yeah, still running. Actually, you can do it on Jupyter notebooks. You can do it on VS Code. It doesn't matter. It's just a Python script. And yeah. And if you got an interest, you can kind of expand this for loop just to get your heads around to see what actually means. Because you could do anything with the for loop and the while loop. And hopefully this should take ages. Yeah, it takes ages. I'm gonna keep going because this one takes ages, and in next step it might take more time. And the step 5 is basically our very last part, is to actually get those review tags and the titles, of course. So if you go to any of the links in the output, you kind of should get like here. No, sorry, this one. And in this page, you can see a lot of movie reviews, and you can see the title here. You can see the title of the movie. So again, we kind of want to get those tags and kind of want to get those titles with the coding, not with our hands. So again, we're gonna locate it where it is, and try to see the pattern of it. So for this review text, you can see it just says text show more, and that's a dev, basically a dev tag, plain tag. And what's so special about it is that it has a class as a text and has a show more control or something. And if you want to reflect it on the code, it basically just saying here, basically you can see the soup find attributes with classes that has tags show more. That's just how you normally get tags from with the beautiful soup to get it on the website. And it might be a little bit challenging, and it's still not loaded. I guess the internet is too slow today, so that's why it's taking ages to request. But if you are at your home, one way to actually to see what is it doing is to actually not really. There's no way to do it because you're not customizing. Beautiful soup. Okay, there it is. There it is. It takes 285 seconds. Oh my gosh. So that's all the reviews we got right now, the review links, and you can actually click into any of them to see what it actually is. Oh, damn. I think I copied the wrong one. Yeah, I copied the wrong one. I'll just copy the second one. Just to show it's right. As you can see, the second one is that thing. And there's a whole lot of other things. Not a whole lot of other things, what I'm talking about. Is everything have anyone got this thing so far? I'm pretty sure no one got it because it's too slow. Oh, you actually got it. On your laptop? Oh, okay, you got the output. Okay, nice. That should be all good. Yes. Okay, let's just go next for the review tags. Again, as I said, there's like a particular text has a particular class, says text show more stuff. That's for the text. And again, we also want to get the title of the movie. I mean, there's different ways. You can complain there's like different ways to get the movie titles. You can literally get it at the very first step at those part. But in this part, I just want to stick to this particular HTML page to see all the contents. So if we go to this reviews one, you can see the title here has this one, the redemption something, and this one got the content. So, that's one way to do that. You can see it here. You can also see the title over here. So you can either get it from this tag, or you can get it from the previous tag. Anything you want. It's just to get the data. It doesn't really matter how you get it. As long as you get it, that's good. So in the actual reflecting of the code, this slightly harder to do because firstly we kind of want to get a list, like an empty list for the reviews and to get the titles for those individual movie. So now you just created two empty lists in your code. Just bear with me. I'm gonna get rid of this. And that's just two empty lists for now. And now what we're going to do is to actually run a for loop. So instead of running a for loop in a list, this time we actually expand it to see it more clearly, of course. So the for loop is saying for the movie review list, which is previously movie review list, is all the review list links in that. So that's all those stuff, all the review links. Is that okay? Okay. Next, in the for loop, what we're going to do is, again, using beautiful soup to kind of request the text. What it's saying is basically going to this part, and it's kind of requesting this whole HTML page, and to see this tag, and to see the other tag. So if you can just try to copy the first few lines here, you can kind of see what it is. Okay, I did a wrong step because I didn't copy the for loop. So I'm just gonna go through line by line. That's a comment line, so don't worry. The review tags, if you remember, we had a movie tag before. So basically, just saying we're just finding this tag, this particular tag, with the class, and the class name is tags, and another class called show more controls. For that one, it will get all the tags from the review tag. And this step, what we're doing is trying to adding those tags to that review tags list. So similarly, for the titles, we're kind of doing the same stuff, getting the tag first and adding that to the actual list. So if we want to see the output, we can basically just print review tags. Oh no, I don't think it's review tags. It should be review text. And I believe again it's gonna take ages because we had the thing before. And has everyone at this step or not? Or you just completely lost? Or not completely lost, but still lost? Everything's okay? Okay. I'm just gonna run it, but I don't expect it to finish in half an hour. No, just kidding. It's gonna take ages, so let's just keep going for the next step, which basically trying to convert it to the CSV file. So for the output, that's basically the output, but we're gonna show it later. And for the actual converted to the CSV file, firstly we need kind of like a data frame. So to actually see what column it is, to actually clean the data. So right now we got this reviews, we got the titles, but I mean for code it doesn't really know what it is, doesn't really know what is movie title, it doesn't really know what is review link, what is permanent link. So for this one we use PD, which stands for pandas actually. And for that one it has a particular, I would say, a method or function that allow us to create those particular data frames. So in this case, it's basically saying, okay, movies gonna have some movie titles, which you can remember before is the movie titles. And for the user review link, the permanent link, it's just setting the list. And for the user reviews, it's actually the review text, the text list we created before. So it's all over the thing we did it before. So that's actually a summarized things. And the final part is basically to transfer that data frame to the CSV file. So you just here, just those parameters, just saying the name is gonna be user reviews and the index is gonna be false. And if we go back to the thing, it's still loading because previously it takes like almost 5 minutes to get it. So is everyone with this step cannot get the idea all right? The idea for converting to CSV all right? Just gonna take time. So one trick is like you can shorten the link in the actual very previous part. Let me get it. So in this link, remember you can kind of customize this link. You can kind of change the count to 1 or change the count to 2 to actually just shorten it to just not gonna get 2 to 100. You can just get 2 or something. Actually, I can show you. Let me just how to terminate. I can't terminate it. So if I change the count to supposedly it doesn't allow me to do that. Change that one to 1. Actually 10, not 1. 10 is too dangerous. And in the terminal, oh sorry, that's a wrong terminal. Code is already running. I hate this. Okay, so if you run here, supposedly it should take less time, because right now in the URL, it is just saying count 10. So that's 10 times 10 is still gonna retrieve 100 still gonna retrieve 10 links, but it's gonna be less. It's gonna cost you less time than 100 links. So that's just one way to change something. And I would say that's almost all of them. So we add this step, and the next step is just convert it to data frame and try to get a CSV. I'll reflect it on the coding part. So once we got those code there, and if we run it, I'm just gonna terminate it. Nah, it's not gonna show you anything. And hopefully it's gonna give you. And important thing is that you actually want to check the URL beforehand. I believe there's something wrong with the URL we're creating. And if this one is okay, it means we can use that URL, unless there are some problems. Oh, sorry, not pip install pandas. Python test. And again, it's gonna take a while because we're going through all those steps in the actual coding part. So remember we had 10 seconds kind of delays. So in your implementation of the assignment, you can, expect it to take a while, but don't give up for the hopes. And as you can see, nothing errors, nothing wrongs out there. So now if I open the thing, you can see there's a CSV over here. Can I zoom in? I can't zoom in. Okay, I can zoom in here. As you can see, there's a CSV file. It basically means we successfully get a CSV file from the actual website, from the IMDb. As you can see here, just getting one, because we just listed one. And the review should be similar, because I didn't remove the duplicates. So in your actual implementation, please remember to kind of remove those duplicates. Otherwise, it's going to get thousands of same stuff, and it's really bad. And is that all good for everyone? Okay. If you got any questions, or you haven't got to this step so far, or you just lost, just raise up your hand. Okay? No? Yes? Bad? Good? Okay, good. And okay, I'll just go. Guys, just one last step. We're gonna create a GitHub account. If you know how to use GitHub, just feel free to ignore me, but I'm pretty sure some of you guys might not know how to upload your files to GitHub. So I'm just gonna show you here. So right now, as you can see, you got all those files on there. And what you do is just go to github.com. If you see something like that, if you see something like this, like sign up, it means or if you have an account, you can just sign in. If you don't have it, just sign up. It's basically gonna just get your email, get your name, and it's gonna be like confirmation email, and that's very simple step. I'm gonna skip this part and come back later, because I just want to show you how to create a repository and upload files in it. So in the actual GitHub things, hopefully most of people is at this step, and then you can just click the green button and click a new one, and just create a new repository and name it with whatever you want. I might say workshop test or something, and you can choose the description, so anything is all optional. And I would suggest using private, but it doesn't really matter for public, I guess. For the assignment, it has to be public, is that right? Okay, so for the assignment, it should be public, so we can actually review it. But if you just want to create a private repository just for testing something, it doesn't really matter. And for this one, you can add README file or not. In this case, I'll just add a README, because eventually you're gonna, I think, submit a Jupyter notebook, and README is a good thing to track down I would say a step. So now if you click the green button, create a repository, you should see something like this. Just a very plain, very started things. And now beside the green button code, you can see add files. You can either upload a file or create a new file. In this case, I'll just show you how to upload it. Basically like a Google Drive. You can just go to your File Explorer or something, or Finders, locate your file, and just drag it in here, and it should be automatically uploaded for you. And again, I can upload another file. My spelling. And now you can see two files gonna upload it. You can customize commits. You don't actually have to learn what commit actually means, but it's just like a message saying, okay, I'm adding the files, I'm adding this stuff. So now you can either create a new branch or something, but by default, they just upload it to your main branch, master branch. And once your committed changes, you should see there immediately, unless it's changed. Okay. Now, if you see here, you got your file test.python. You can actually see all your code you wrote before, and basically a Google Drive, but for developers or for coding stuff. And the CSV is over here. So that's basically like how to create a repo and how to upload files. If anyone got a question on that, feel free to raise up your hand. Or if anyone haven't created a GitHub account, just feel free to raise your hand. All those people will help you. And that should be it for my part. Is everything okay? Nice. Okay. If everything's okay, I'm just going to go around and to see the process of each person.
Cool. Before we start, how many of you have actually gone to the website and to Kaggle and actually signed up for the competition? Can you raise your hands? Cool. It's good if all of you guys do it, because there is a deadline for the competition itself that is very soon. It is tomorrow. This is not the deadline for submitting your entries. This is just a deadline to sign up and enter. So just go to the website and just there should be a button saying enter competition somewhere. Make sure you get an account and click on that before tomorrow. Yeah. Cool. We'll get started. Hopefully everybody's signed up to the Kaggle competition. I'll just recap about the competition. So today's workshop will be covering the basic stuff to do with the basic requirements, and next week's one will basically be focusing on the more of the advanced ones. We'll be doing the Power BI one today, but except for that, we'll do more of the basic machine learning stuff today. And throughout, I'm going to be presenting some slides, and if you have any questions, feel free to raise your hand and shout if I don't see you. Anything else I should mention? So good. And if you have questions, yeah. So I'll start right from the beginning, which is basically what is machine learning. So I'll go through it relatively fast because hopefully you guys are a little bit familiar now. But it's basically essentially finding patterns in data. So it's basically, you can, like, the easiest way to think of it is that you're mapping a set of inputs to a set of outputs with this weird mathematical function. And that's not really that's not all machine learning. So that is a specific version of machine learning called supervised learning. There are other types, which is unsupervised learning and reinforcement learning, which we won't talk about because we don't have time. But supervised learning is the main thing that's used in industry. So unsupervised is where you don't have labels for your data. And reinforcement learning is where an agent learns in an environment by receiving sort of decisions and rewards from the environment. So under supervised learning, there's also two types of tasks, classification and regression. So classification is when you have multiple, like, discrete outputs. So for example, you're given a picture of a picture, and then you have to classify if it's a cat or a dog. So those are two discrete categories. Whereas regression is you're predicting more of a real number. So you're predicting like the rainfall, or in the Kaggle competition, you're actually having a regression task, which is you're predicting a number between, I don't remember, -1 and 1 or something. But so the thing to note is most of the online tutorials might be geared towards classification, and you may have to change it a little bit to make it work for regression. So the other thing terminology-wise is AI, machine learning, deep learning. So artificial intelligence is sort of a pretty vague term. You can think of machine learning as sort of a subset of that, which deals with more statistical and mathematical, like algorithms and things. And deep learning is a subset of that, which basically these days is neural networks are synonymous with deep learning, but it's basically a neural network with multiple layers. But I'll go through this with an example. So an example of an artificial intelligence system is a self-driving car. So within that artificial intelligence system, there'll be multiple things going on. So for example, for an AI car to work, it'll need to do perception, prediction, planning, for example. Perception is basically detecting what's on the road. Prediction is how those things move. And then based on those two things, you can plan where the car has to go. So in that case, each of these, you can think of it as a machine learning problem. And for example, perception, you can use deep learning to detect vehicles. So you can sort of get the idea of, that's the general framework that I sort of think of when I think of AI, machine learning, deep learning. And there's another thing we need to talk about, which is the sort of data science life cycle, or the like in terms of how machine learning and data science works in the real world. You usually start with a business problem or some sort of problem that you're trying to solve. And then you sort of frame it as a machine learning, or you can frame it as a machine learning problem or some other sort of problem. And after you've framed it as a problem, you basically collect data and train a machine learning model to basically give the output that you want. So in the assignment, we're basically covering quite a few of those things, just to give you a taste of. So we're giving you a business case, and then you're given some data, but you also have to scrape some data from the Gutenberg archive to feed into your model. There's a few things that and in the advanced requirements, we want you to deploy that model as well. So there's a few things that might trip you up in the assignment that I'll talk about. So the first part, I guess, one of the parts you can get tripped up is the data you're scraping. You need to get it into a format that it is useful for the model. So that part is not very well defined in the assignment, and that's on purpose. So you're basically given a database of books, and you're given the whole book. And generally, if you try to feed the whole book into the model, it probably won't work. So you need to come up with a creative way of solving that problem is one thing that, as a data scientist, you would definitely need to do as well, types of problems. And the other thing is the model output is also not very well defined. So you're getting a number between -1 and +5, I don't remember. But you're getting a real number, and interpreting that result is also up to you in the assignment. So you basically need to come up with a creative way of sort of converting that output into something useful. And that is what you would do as a data scientist in the industry as well. And then we'll be going through deployment, which basically makes use of the model. So we'll go through how neural nets work, a bit about deep learning and neural nets, just so you have a foundational understanding of how the sort of the deepest layers of it work. Because nowadays you actually don't need to understand a lot about some stuff, but it's useful to know the fundamentals. And in the advanced workshop, we'll be going through more advanced, more the state-of-the-art stuff. And teaching that stuff will take quite a lot of time, so we will just tell you how to use it. But it's good to know about the sort of fundamentals. So on the left is basically a picture of a real neuron. It's got a bunch of inputs, a body, and a bunch of outputs is all you need to know, really. And a neural net, deep learning is basically a sort of cartoon version of that, where you can think of deep learning as representation learning, where you have a bunch of inputs and a bunch of outputs, and each of these new layers of the neural network are trying to sort of create features from the. We'll get through that later, but basically it's basically trying to detect patterns in the input image, and then the output layer basically makes the decision on what it's supposed to be doing. So deep learning, neural nets is not that recent. Like the fundamental research started in 1950s, and then it died off a little bit, and then it's been coming back, especially since 2012. So some of the early research, 2012 was like a images type of thing, but the earliest deep learning stuff was actually on speech with Jeffrey Hinton and people. And then this is the ImageNet challenges basically in 2012 what made deep learning popular. It's basically a competition where you have to detect 1,000 object categories. And you can see from 2010, 2011 was around 25% error. And then there was a quite a bit of improvement, and that was because of a AlexNet network, a deep neural network basically, and that after that they've been state of the art. And the neural networks do come in a lot of flavors. We won't be going through all of them, but we'll be going through the most simple one. So we'll start with linear regression, and then we'll move on to neural nets with a basic example, which is probably very easy to do figure out. So we'll come up with this example, which is you go to a fish and chip shop and you order 2 fish, 1 chips, and 1 tomato sauce, and you get charged $12. And your task is to figure out, there's no menu, and your task is to figure out how much the fish cost and the chips and sauce cost individually. How would you go about doing that? Basically, I'll go through how to do that, but maybe you collect some data. The first thing you do, you get multiple people to go to the fish and chip shop, and you get them to buy different things, and then you see what their total is. So this is a data set, and each of these columns are called features, and each of the rows are samples, or there's different names for it. But from this data set, to do linear regression, you will multiply each of these numbers by another number and add them together. You may have come across this formula here. And the x's would be the price of the number of fish, and the m would be your guess on how much the fish cost. And that's basically the formula for linear regression. So one way you could do that, there's multiple ways of doing it, but I'll go through the one that's more similar to the neural net way, which is the gradient descent way, but actually linear regression usually uses a different formula, but you don't have to worry about that. So one way to do it is you basically make some random guesses on what each of those things cost. Maybe you said the fish cost $3, the chips cost $11, and the sauce cost $7. And you work out 3 times 2 plus 10 times 1 plus 7. I don't think that's right, but $27. Just say, and then you know what it actually costs, which is $12, and the difference between those two is called the error, and that error is what is used to update those numbers. And firstly, talking about the error, there are different error functions you can use, and there are advantages and disadvantages for them. So the basic one, the mean absolute error, is basically the difference between the two. You get the absolute number of the difference, because if you add them up, otherwise you usually get 0, which is not a very useful thing. In the assignment, I believe they want you to report the root mean square error, and the lower the root mean square error you get in the competition, the better your model is. That is what determines if your model is good in that competition. So for the root mean square error, you get the actual number, which is 12, minus 27, and you square it. And then this is just one sample, but you do it for all of the samples and get the average. And then you square root that, is the root mean square error. And then in gradient, so how do we change these numbers in the middle? We change them by basically using gradient descent, in which you calculate the gradient of the error, which is a bit complicated to explain and backpropagation is used to update those weights. I'm not going to go through backpropagation in this presentation because it'll take a while. But basically, each of those errors, you calculate the gradient of the error, basically how much that error changes when each of those numbers change. And then you use that to update the numbers. So each of those weights would be the old weight plus this parameter called the learning rate times by the gradient. I think it's minus, but basically this learning rate determines how big the steps are between like how big of a step in that direction you want to take. So we don't want it too low because it'll take a really long time. So what you're trying to do is trying to get to the bottom of this loss landscape, or the so you can think of the output at certain numbers. The output is minimized, and you're basically trying to minimize the error. And if your learning rate is too high, it'll just bounce around too much, and if it's too low, it'll take a long time to get to the minimum. So you want something in the middle. And there are different optimization techniques to update this as well that are more complicated, that I'm not going to go through. But if you do want to Google these names, you can. Basically, in the fish and chips example, what I went through is just linear regression, but I also connected it to a little bit of neural nets. But this is a neural network. This is a neuron. So neuron is basically only very slightly different from linear regression. So you still have the bunch of weights, the bunch of inputs, and the summation, but there is also this nonlinear function that after it's been summed, it goes through. And this nonlinear function is basically what enables the neurons to model nonlinear things, because the summation is only able to sort of find your function in a very smaller space. And if your function is more complicated, this nonlinear function is able to sort of model the nonlinearities in the data. And this nonlinear function, there are different ones you can use for it. So the sigmoid and tanh were used quite regularly before, but nowadays I think the most commonly used one is the ReLU function, which is basically if your sum of all the weights times the inputs is less than 0, you basically set the output as 0. And if it's positive, then you leave it as it is. And a neural network is basically, that's a neuron, so the summation and the nonlinear activation function. And a neural network is basically a collection of these neurons, and that's essentially what a neural network is. It does get more complicated, but we won't go through the more complicated stuff, but we'll go through some of the more complicated transformers and things in the next lecture and how to use them. But in terms of theory-wise, I can point you to some resources so you can have a look. But the other thing we have to deal with is computers or machine learning models can only deal with numbers. And what you usually get with data, images and text is not really numbers. So because in the assignment is text, natural language based, we will go through the natural language example, but you can also convert images to numbers as well. So one way that you might imagine converting a sentence into a bunch of numbers is one-hot encoding, is what it's called. So you basically, the cat sat on the mat, there would be represented by this vector here, and cat would be represented by this vector, and then sat would be represented by this one. So the cat sat on the mat would be this number followed by this number followed by this number followed by, there's no on, but you get the idea. This is not the there are a few things wrong with this, but one thing that it's not always useful for the algorithm is because the common words are not really. So if for example the cat sat on the map gets converted to this vector here, so there's on is on mat, and there's two there's and one sat. If you look at this number, you can't really figure, it's something to do with on, mat, sat, and the cat. And you can see the has two, and that's because there's two the's, but it doesn't really contribute that much to the meaning of the word. If someone tells you to tell me what this sentence and this sentence was about, this is about the dog and the bed, maybe you can get it, but basically, for example, having this two here, the common words get highlighted much more than you would want. So one way of avoiding this that I will go through in the notebook that I will do is called TF-IDF, and that's sort of a way to minimize the impact of like very common words and maximize the impact of, if a word is quite rare in a sentence, it actually has quite a bit of meaning. So for example, if you don't have to go through, it's basically the term frequency multiplied by the inverse document frequency. So it basically looks through the whole data set and sees how many times that word appears in that whole document, and then scales the number of times it appears in this document by that factor to get a sort of different set of numbers. So if I convert the same two sentences through TF-IDF, you get these numbers. So in this one, you can see that the has 0, because both of these sentences had the, and I think it got cancelled out. But you can see this sentence is about the cat. It's easier to see that it is about the mat and the cat, and this one is about the dog and bed, and my dog and bed. So you can see that the machine learning algorithm might have an easier time working out the sentiment or the meaning when that scaling thing is taken into account. This is just one of the ways, and there are many other NLP techniques that you can use to convert text to numbers. And then before you do this, you would have noticed that these are all lowercase, because you can also, like, there are transformations you can do to make sure that, especially in your assignment, like, it doesn't matter if mat is capitalized or the cat is capitalized. So you would usually convert all that, everything to lowercase, and then you might combine words like developing. All of these mean similar things, so you might use a technique called stemming to sort of have one word to represent all of them. And there are other NLP techniques you can use. These are generally like traditional NLP techniques, natural language processing techniques, but most of the newer neural network models use this thing called an embedding layer. So you basically convert, what the advantages of an embedding layer is that similar words get mapped to similar locations on the, so in terms of embedding is just a bunch of numbers. So the cat is represented by 4 numbers, and each of these numbers can be any real number as well. And these are trained so that similar words have similar numbers in vector space, if you can think of. So, and the other thing is you can also sometimes do some vector arithmetic on these numbers as well. So for example, if you take the distance or the subtract king from queen, you might get a similar number to if you subtract man from woman type thing. So it sort of embeds a bunch of meaning into these numbers basically before they're fed in, so that the machine learning algorithm is better able to sort of, it's easier for the main algorithm to understand what these are about. And this algorithm is usually called, like a popular algorithm of this type is called the word-to-vec algorithm. You can Google that to find a bit more about it. But it's essentially just it's a bunch of linear neurons that basically go from that one hot encoding into a bunch of numbers. It's a bit more complicated than that, but it's essentially, you can use it in other algorithms as well. So here you can see fried chicken and chicken fried rice might be closer in the embedding space than, I'm not too sure what this is trying to say, but So chicken fried rice and shrimp fried rice is close together, but chicken waffle and fried chicken are close together, even though they have chicken fried in both of them. Maybe not. Basically, the other thing you have to know before is training data, validation data, and testing data. So in the Kaggle dataset, you're given a train dataset and a test dataset. So the test dataset they give you should be a validation dataset, because there is another final. There is more. There can be more than one test set. So the test set they give you is basically for you to use as a test set as well. But they also have another test set behind their wall that you would only get when you submit the notebook, that they will test your model against, so that you can't sort of overfit and cheat on the testing data set. But usually, once you get the training data, you would still split it up into training set, validation set, and testing set. And you would use your training set to train your model. And you would use your validation set to sort of tune the model and change some numbers in the model so that you get good results in the validation set. And then you would use the testing set only a few times just to see if the model is not overfitting to that data. So which means I need to explain overfitting and underfitting. So you can overfit to your data set or underfit. So underfitting usually means you're putting a linear model, for example. If you had to draw a line between the red points and the blue dots and the red X's, one way you can do it is you can draw this line. That will be a linear decision boundary, but it will be underfitting because that's probably not the best way you can draw the line. So this is sort of like appropriately fit, and you sort of have a curly line. The other thing you can do is you can overfit, tune your model so much that it doesn't become useful. So your decision boundary is like you'd sort of draw some sort of very weird shape. This means you probably won't get good results on new data that comes in. So in this case, the appropriately fitted model is probably the one that's going to give you the best results in a real world setting. There are a few resources, but I will go through, we'll do some coding. I'll actually submit one on this one, just so you know how to enter the Kaggle competition as well. So for example, if you go to code, you can start a new notebook. And I'll just steal from here. And you can see Peter did go through this a bit, so I won't go through too much, but they've already imported pandas and NumPy for us. And you can see you can add our data set, which is this one here. You can just add it. And then it'll come up on your input files. So you have these three files you can see on that virtual machine. So you would first read this into a data frame, a pandas data frame, train data, let's call it. And using pandas read CSV, and then you pass in this file. You can code along with me if you want, but so this is the trained data. You can see the excerpt, the target, and the standard error. So in the, we'll also load the test data, which is the same one, but And the test data also has an exit and an ID. I will copy from my other one. So in terms of, there's a few other things we can import. Just give me 1 second while I set this up. Oh yeah, any questions? I forgot to ask. Sorry? The PowerPoint?
The slides.
I did try to put it on GitHub. Is it not on GitHub yet? Is it a pull request? I'll make sure it's on there. It's not there yet, but I will put it there. I can probably put. My internet is not working. I don't know why my internet is not working. Any other questions about the machine learning theory part, maybe? Has everyone got a notebook up and running? Maybe have a go at that while I. So for vectorizing, I will show you how you can do the vectorizing, which is we're going to use the scikit-learn library first. We're going to use the TF-IDF one. Maybe we'll go to the user guide. No, there should be something here as well. So we'll use the TF-IDF vectorizer. And you can see what sort of arguments you do pass into this. But so to do that, you basically need to initialize. Oops, not that. You basically need to import it first, which is just that. And then vectorizer is it's just that dot. No, it's just. You can feed in your own stop words. I'll have an explain stop words. Let's just do this TF vectorizer, and then you do vectorizer dot fit transform. to fit and transform your data in one go. And we will do train data with the excerpt column, because the excerpt column is the column with the data we want. And it's expecting a NumPy array. So just to get the values from that, you just do dot values. And then we'll set that as the X for our purposes. So if you do this, you can see you get a special a 2834, which is the number of rows in our data set, by 26,000 wide column. So that means in this excerpts there's around 26,000 words, and that is too many words for us to deal with in this tutorial anyway. So you can see what words it did do a TF-IDF for by doing get feature names. It should be there. What is it? So if you go to methods, there is a get feature names here. Probably misspelled it. So you can see it basically created a vector, basically something like this for 26,000 words, which is too many words. So we sort of want to limit it, and also do some make sure that it's not getting the very, very common words, which are the stop words, which are words like it, they, are, a, it type words. And it is interesting because it like vectorize this one already does remove the exclamation mark, the punctuation and things, but there are like a bunch of numbers as well. It'll be good to get rid of those as well. So to do that, you would pass, there's an easy way of just passing in some variable values to this. So we probably do stop words equals English. You can just look at the documentation to get these. And we're going to limit, there's a feature called max features, and we maybe only want the top 2,000 words on the whole document to be fed into the model, because that'll definitely make our machine learning model's life easier if it only has to deal with 2,000 numbers. And this is just an example. You can play around with more complicated stuff later, but what other options do they have? It's also, they also have a regex token pattern, so I think it matches all. So you can also see it all converts everything to lowercase already, but we'll just enforce that. And then token pattern, there should be a way of getting not just any pattern, but just numbers. So we'll try this, which is U is, I believe, any Unicode one, but I only want it. I don't actually remember. Does that work? Okay. Don't worry about this one then. No, I think it just needs an extra thing. don't worry about the regex pattern, but we'll keep lowercase. And then you can see now it's just got 2,000 features, and those 2,000 features are mostly words that would be useful, hopefully, to the model. So we've got the vectorizer, and the y is the target. So y is the trained data. We'll get the, what is it? Target. So y is the numbers. You can use the standard error as well, but I think they only require the target as the output. But you can use the other data as information if it's useful for the model. So before we next split the data into train and test split, which I will Google as well. Just so you know how it's easier to copy paste, but you know where to find it as well if I do it this way. So you first need to import it, which is you import it and then run it. We'll make the test size 20%. That means 80% of the data set is used for this training, and then just so we don't get confused, we'll make this validation. And you can see the xtrain dot. The xtrain is 2,200 examples, and the xval is 567 examples. So we basically split the data set into that many things. These are still sparse matrix, which is enough. The next thing we do is you can actually look at how the vectorizer works. One thing we can do is see how the vectorizer works. So if I just take the first excerpt, the 0th one, I can print that, and this is this paragraph. You can do vectorizer.transform, and it's actually expecting a list, so we sort of need to change it a little bit. Oops. So we changed this one. It's expecting a list, so I will just do this, and then even if I do this, it'll be similar. It'll give you a listish, and then to actually look at the number, you do to array, because it's a sparse array. You can see there's around, if you see the size, it's a array 2,000 wide and 1 high, which is full of zeros, but you can plot it. The easiest way I found is to convert it to a data frame, and then I'm gonna flip the axes from, so it looks like this, and then I can plot it with the built-in plotting thing. So you can see it's got 2,000 features, and some of them are pretty high, the numbers, and then quite a lot of them are zeros. So that is our representation. Yeah. Yep, sure. So except wise. So we basically have this paragraph from the data set. So when the young people returned to the ballroom, it presented a decidedly changed appearance. This sentence we want to convert it to a number. So that's what the vectorizer did. So this TF-IDF vectorizer basically took that sentence and converted into a number, 2,000 numbers. So each of those locations in that 2,000 word vector stands for how much of like each of these words is in the array. So what it's doing is basically that. So the cat sat on the mat gets converted to this here. So the cat has a certain value and the mat has a certain value. The in this case doesn't have a value because it's on both, so it sort of gets cancelled out, both sentences. But so the really common words get relatively, if the rare the words are in that document, they'll get a higher score. But it's basically essentially similar to having ones and zeros, but the ones and zeros are scaled by how rare that word is. So the rarer words get higher scores in that vector. Do people understand? Or maybe not? It's basically a way to convert a sentence to a number. I won't. I'll change this. I'll upload a similar. Yes. The pre-processing code will be, but I won't. I'm going to train a model now, but I won't put the model up. So you guys will have to do the actual thing yourself. But the pre-processing stuff, the code is there, I believe. So once you basically create this vector, so you've basically created a data set that is ready to be fed into a machine learning model. So if you do it looks like a bunch of zeros, but it's actually got a, yeah.
On the x-axis,
Yeah.
0 to the 1,000 is just the index of the word, right?
Yeah. And then this number is yeah, it's this number here. So yeah. And then you can see most of the numbers are 0, but maybe the 2,257th number is, you can actually convert that to, where's this? Is that right? Yes. So you can see that this word, this 2,266 sentence has yellow in it, and we can probably check that as well if we do 2267. Can you see yellow in this one? No. Maybe it's been shuffled. Let's just do. No, that doesn't work. Vectorizer.transform. We'll put that one there as well. This looks slightly different. So you can see the third one has the word year in it, hopefully. It's there, I guess. And if it's so it basically converts each of those into these 2,000 words. And that means this X train is ready to be put into a array. Is basically ready to be put into a 2 array. A machine learning model. So let's make a machine learning model. So we'll create a simple neural network. We're looking for regression, so we go to regression. And nearest neighbors neural network we're looking for regression as well. So we have MLP regressor for the regression part. And to do this, you can go here and see what you need to do. We've already done this one, but MLP regressor, we import that. And then we've done this. And the regression, we initialize the regressor. You can change a few things. The main thing we can probably change is the number of the hidden layer sizes. So let's have a go at changing that. Right here. If you do hold shift tab, you get the menu sometimes, usually. And maybe we'll have these are sort of not magic numbers. You can pick whatever numbers you want. Maybe we say the first layer has to have 512 neurons. The second layer is 1,000 neurons, and the third layer is 512 neurons. And there's a bunch of other stuff. The activation function is the ReLU activation function. That was this one here. And the solver is Adam, is the optimizer, which I did not explain that much, but it's the different optimizers here. And then the learning rate is constant, which means learning rate init. So the default is 0.001. You can play around with that number as well, see if you get better results. And just have a read of these ones and see if any of those are relevant. But usually the defaults, scikit-learn is made in a way, the library we're using, the defaults work sometimes. But you don't actually need to play around with the defaults if something you want to change. But the defaults are not too bad. And then after we've got this model object, you need to do fit on our data. In this case, X train and Y train. So Y train has our target variables. And the training will take some time. While that finishes, we can, let's wait for that to finish. And then there are obviously other models you can choose from as well in this library, but we'll go through one of the more complicated libraries in the next week. but good ones to start is probably random forests is another good one. Support vector machines, linear regression. You can play around with some of these methods. Ada boost. But for now we'll use the this one. It looks like it's finished training, which means you can use it to predict. Now before we predict, it also gives you a score. The score you should check what it is. Returns the coefficient of determination or the R squared, which means how correlated your outputs are to the actual labels. So let's check we can check the performance, regr dot score. We can check the performance on the training data set, which is hopefully pretty high, but you would see that the performance on the test set is much lower, and that's usually a sign of overfitting. But so the easier way to check is we'll graph it. I'm importing this plotting library, the most basic one. And that's just to make sure the Jupyter Notebook shows the graphs inside the cells. plt.plot. So we'll try predicting on the training set. So we get this one, and then we can run the predict function. On the X train. So that's the so we'll plot the Y train with the predictions, and you can see I will change it to black circles or something, blue circles. You can see it. So X would be the real label, and Y should be the prediction, and you can see they sort of match up in the training set. But if you look at the test set, which is what the data that the model hasn't seen, it'll be quite a bit worse. It's quite a lot. And then we can probably do test spreads and then Y test. You can see it's generally still pretty good, but there is obviously a bit less good than this one. So right now, the REGR is basically the model we have. So the task in your assignment, in the competition, is basically you're trying to minimize the root mean square error. So we'll check the root mean square error as well. They definitely have a mean squared error. So we'll calculate the error, the mean squared error. And then mean squared error needs 2 arguments, which are the needs the y true and the y pred. Y true is y. We'll check the train first, and then y. No train preds. What did I training preds? You can see the mean square error is quite low on the training data set, but on the testing data set, we would probably. That's actually a pretty good model. It's 0.35 mean squared error. So now we've got a model, and we think it's pretty good. And then we can play around with the model parameters as well. But before we submit to the competition, we usually train it one last time with the entire data set. So we will do that here. We'll fit it on the X and the Y. And then we have to get the actual test set we make the submission with. So in this, we got the train data and also the test data. Actually, ideally, we should be training the. Oh yeah, we did. Well, there might be some data leakage. We're going to fit this model, and we're going to. So we've got the test data. It's got an except column as well. If we see up here, we take the except column, we feed it through the model to the tokenizer, the vectorizer, and then get the results, and the results are what we're submitting. So the except, we pass it through the vectorizer, which we do by vectorizer.transform. And we get X test from that. And then the test set is actually quite small in this one. It's actually 7. I was quite surprised it's only 7. But they will basically replace this 7 test set with a much bigger test set when they're doing the actual evaluation. So that's how they sort of get around that, your code. So the test needs to work with a bigger test set. And then we will do the predictions on the test set by getting the thing we just trained and then predicting using it. And we feed in X test. You can see the preds are. Let's look at the X test. The test data accepts. We'll check the 0th one. My hope in Lay's Jack Prom is a bright light, whatever. It's negative 1.6. Maybe we try to find a there is no positive ones here. Oh no. Oh, didn't I?
Because when you train it, you use a transform on scale, and when you do a prediction, you do it with scale.
The transform one.
There's a feature scale.
yeah, scaling it between 0 to 1 would have given better results. You mean?
When you train the model, every
Yeah.
data set is scaled.
Yeah.
But when you do a prediction, you're using the pre-scale.
What do you mean pre-scale one? The vectorizer one. This one.
Using non-phase, not the sort of scale.
It gives, because the vectorizer usually gives numbers between negative 0 and 0, and so the vectorizer outputs are usually not too bad. Yeah, it's between 0 and 1. So it's already scaled. But generally, if you do use a neural network, that's an important point. Remember to scale the inputs. Make sure they're always not more than 1, like 0 to 1, or with a standard mean and standard deviation between, like with a mean of 0 and a standard deviation of 1, or do some sort of scaling, especially when you're dealing with neural networks. It's less important when you're dealing with random forests, but definitely quite important when you're dealing with neural nets. But what I did do wrong here is when you're initially vectorizing, you shouldn't be vectorizing on the whole trained data set either if you're going to be using another validation set. So I should have fitted it only on the X-trained data set, and then right at the end train it on the entire data set. But yeah, that's what I should have done. But because otherwise there's sort of data leakage from because the validation data is also in that vectorizing part. There's a sort of like what you call data leakage as well. But yeah, for scaling wise, I think the numbers are fine, the input numbers. Yeah, you can see. And then once you've got these predictions, you can see this is negative 1.6, and it's generally advanced. Let's try so this one is, the fifth one is relatively. They're both quite complicated texts. So I guess it might be more complicated. So this one, the sixth one, is generally looks a bit more readable. But after, we'll submit the predictions. I think I just copied this from. Let's just do what Peter did, which is basically what I did. So your predictions would be the test preds here. Oops. And then it's not called test df, it's called test data. And you can see your predictions. So this is what you are supposed to be submitting. And if you do want to submit, I believe, as Peter said, you need to turn off internet. You do have the option to use GPUs and TPUs, especially for the transformer and deep learning based ones. This will be useful. Environment is the standard one. I will save this as tutorial. And then when you actually want to submit it, I'll just go straight from here. That's 2021, phase 2. No, that's a different assignment. Not that one. So I should probably, hopefully now be able to After this is finished running, I should be able to submit my notebook. Now we'll close this. Okay, you can see the notebook version is tutorial. No output files found. I think I just have to wait till the code finishes running. But until the code finishes running, any questions? Data. My submissions. I did do one before. Am I supposed to? I think I'm supposed to wait till it finishes. So let's wait till it runs. In which case I don't actually need to train two of them. So we went through, so in the technical report, you need to submit something like this with that is better commented. I mean, you should explain with comments or with markdown everything that you did and how you tested the models and different variations. That's what we sort of expect in the technical one. And in this one, scrape the books, and then this one is more of a interpretation of the results from your book scraping. And then in the advanced requirements, today we'll go through Power BI, and also next week we'll be looking at how to use the Hugging Face library and a bit how to deploy the model and the Microsoft Bot framework, basically. So those are the advanced requirements. Any questions? This one failed. I'm not too sure why. But essentially, would be good if it doesn't fail. Let's see if this works. Oh no, that won't work either. Never mind. Okay, we'll just okay, maybe I'll run it now, and then Chalu can go through the Power BI ones, and then we'll come back to this. And let me know if you have a question. I'll push it onto.
Can I just pull up the README on this? I'm just gonna go through the README. It's been a while. Yeah, I'm just gonna use the. Where is it? Where is it? Wait, where's the thing? Okay, so we're just gonna go through the README because a lot of people don't have Power BI installed on their laptops, and if you have a Mac, you actually can't run Power BI on your laptop. So what you can do is run Parallels and then download Windows and then run it through that, or like dual boot your laptop and download it through that. But we'll just go through how to actually gather data with APIs on Power BI. So for this tutorial, we'll be using Alpha Vantage, which is just this website. You can get a free API key, and they do have like some stock API documentation. And so we're going to be using the time series monthly function. So this is basically going to analyze like time series data of stocks. So this is what you should see when you go on here. And it should just be, it should just be down here, and we're gonna need this link after you've already gotten your free API key. So we're gonna use this to get the data from web. So click on, when you open Power BI, you'll see this starting screen. We're gonna need to click on Get Data and use the link from time series monthly here. So click on web and paste the URL from there, and then this should pull the data from that. Because what API is basically like a sort of like a contract between the information providers and the information users, and this is just pulling all that data from there. And so you should see something like this once you've actually imported the data after clicking OK. And what you want to do is go back to converted to table, because it does all these steps for you, but you just want to go back to this because this is not the way that we want to start our page. So once you get to here, you'd want to expand the monthly time series data and then convert it into a table. So we'll have a table of all of the data through the time period that we're looking at. And then so you should get something like this. And so you'll have all these dates and all of the values, but they're sort of compressed into their own tables. So when you expand that, you should be able to see all of the stock data, like the open value, the high value, low value, close, and the volume purchased. So once you expand that, you'll get something that looks like this menu. Sorry, I don't know why there's a circle on that, but just click OK, and it should expand it to this, and this is your data set. And so the thing with Power BI is that you can use a Power Query editor to sort of manipulate data through the advanced editor. And the advanced editor uses a language called M, so it's quite specific. And when you click on the advanced editor, you'll see this. This is basically what we have as soon as we import it. Like, you don't need to write this. This just shows up on your screen. This thing on top, the query question mark function stuff, it's just the title, just the name of the function, because you haven't named the function yet, so don't worry about that. But we're going to need to be changing what's in this box. And the code is over here, and it's also in the GitHub folder for Power BI. So you'll see this. So basically we're changing this to this. We're making it a function of symbol. So we're going to use web.content, which is basically something that it gets the data from the web page and the web services. So it's basically getting the contents from the URL, which is this, and giving it like these parameters like relative path and query. It just adds some extra text to the base URL, and this is the base URL because this is where we're pulling our data from. This is basically this part of the URL, so it's just kind of expanding that. And I stored API key as a parameter so you wouldn't see it, because you all get your own like private API key, so like you wouldn't usually want to share that. So I stored it here as a parameter, and I'll show you how to put that in afterwards. But yeah, so we're basically putting this instead of that. and it should make the function dynamic rather than static. Because if we have this, we're basically just pulling all of the data from here. So if you click on this is the data that you're getting. It's static, it's not changing. But if you make it a function, it can update with your input. So symbol equals symbol is just saying that the symbol is not going to just be here, like it says IBM. It's not going to just be IBM, you're going to be inputting it. So you can put Microsoft, so MS, FT, IBM, and it's going to pull data on those stocks and put it into your Power BI. So here API key is stored as a parameter, and I'll show you how to do that now. So over here in this sort of space, just right click and you should see new parameter. So when you create a new parameter, title it API key, and then put your API key from AlphaVantage here, and that should store it as a parameter on like the side of your Power BI. And then there's another. So once you press OK, that should work. There shouldn't be any syntax errors. There's on the ribbon, there's an option called Enter Data. So just enter data, change the column value to stocks, and then IBM and Microsoft are just examples of like inputs that we can put into this function. So putting IBM and Microsoft means that this symbol is changing to IBM and Microsoft, because those are like our inputs. So we have that, and you can just change the name of the table to whatever you want. I just made it stock tickers, but you can do what you want to do with it. And then so what we're going to want to do with this is apply the function that we created in the previous step, and that's going to pull data based on the row values. So if we highlight the column, go to add column and click on invoke custom function, we can apply the function that we created a bit earlier. So I renamed it to function 1, but that's basically this. This is function 1, what we did earlier. So if you apply that, you'll get this, and this table is basically just, it contains all of the data that we saw earlier, but sort of like based on the attributes that we input into the column. So what else another thing that we can do is just change the values of the columns to make them more sort of understandable. So, there's no picture, but you should be getting like a full table of data for each of these stocks. I'll add that to the README because I don't think that the screenshot actually added, but you're gonna need to tidy the data as well, because sometimes like Power BI doesn't automatically convert the data types to the ones that you'd want. So for example, date here is stored as text, and you'd want to change it to date. So you'd be able to filter the data based on the date. So you just right click on the column, change type, and then change it to date. And then the same thing goes for like the highs and the lows. You'd want to change them to decimals because at the moment they're text formats, but we'll do that a bit later. So if you select stock and date and unpivot the other columns, we're going to be pivoting the data from wide to long. So all of the values will be in one column rather than having them separated into open, high, low, volume, etc. And so once you have that, you can change the data type of value to decimal number, and then you can close and apply, and then you can start applying visualizations on Power BI. So Power BI looks like this once you've closed the like transformation data tab. And so you can start with visualizations. Since we're doing stocks, you would typically use like line charts for sort of like time series analysis and stuff. So we'll use the line chart, and if you drag the date and the value to x's and values respectively, that sort of creates like a visualization based on those two parameters. So we're looking at values over a span of like this many years or months or something. So you'd want to then drag like attributes and stocks to the filter, so you can filter the data based on sort of like whether it's IBM, it's Microsoft. You're looking at opening values, high values, low values. And then you'd be able to create visualizations like this. This button down here just sort of, it drills down on the hierarchy. So you'd be looking at yearly data here, but if you click drilling down, it goes based on like quarters, dates, and yeah. and then you can sort of play around with the data from there. This is a graph of Microsoft's closing values from 2000 to 2020. So it looks a bit different from, say, these ones because we're using different filters and different parameters. So yeah, and there's a bunch of other resources on how to do these. I'm gonna link a bit more than just these, but yeah, there's a lot of like ways to visualize on Power BI. There's also a link somewhere here of the different types of visualizations that you can use. Because based on the purpose, based on sort of like your purpose and stuff, you'd be wanting to use different types of visualizations. For example, if you're looking at ratios, you'd use pie charts and stuff like that. So this is a link for that. But yeah, that's pretty much it, I think. So yeah. Yeah. Sorry?
Assignment.
For the dashboard? I think Maria's presenting the dashboard next week.
Yeah. Okay. Sounds good. Sounds good. I think we'll have a look at the that model I just trained, and then we'll.
Okay.
Yeah. Thanks. Okay. So in order to, we'll finish off by submitting the notebook we created on Kaggle. Let's just go back to Kaggle. Yeah. In order to submit a prediction, you basically click the submission that we just ran, which was this one, and you just click submit. And it should run your code on the rest of the 30% of more test data. And then it'll give you a score. So I did this one before, and I got a score of 0.83. So hopefully that's sort of a benchmark that you guys can do better than. So the lower the better. So for example, the one that Peter did, he got a score of 1.4, but that was just tested, like setting everything at 0. So you'll if it's higher than 1.4, you have to be quite worried, because just predicting 0 gets you 1.4. And my first attempt got 0.83, and I'm not too sure about this one. So we will refresh the site and see. While this is running, any questions? I think this is most of the stuff we wanted to cover today. If there's any other questions, especially on the basic section, let us know. We'll be going through more of the advanced requirements in the next section. Anybody not clear about anything in the assignment, or any questions on how you might go about doing things? Sorry? GitHub. So there's two things for the assignment. One is uploading your source code. Uploading. So submission wise, for number one, we just want you to have completed the Kaggle competition. The technical report might be usually a Jupyter notebook, or you can submit a PDF on your technical part, how you develop the model. And that'll be a Jupyter notebook you upload onto GitHub. And then number three, we do want to see your code from scraping the books. And then for the fourth one will be a PDF. And all of that you would put on a GitHub, on a GitHub project repo, and submit, give us the link, and make sure it's public. And then the second deliverable is the presentation. And in the presentation, you have 7 minutes basically to go through what you did, highlight any advanced things you did and any interesting things you did. And we'll have some questions around either the technical part or the business case or the scraping part, basically. Submission. Okay, so this one, the one we just did, scored 0.8. So your task is to beat that number if you can. Cool. And yeah, if there's no other questions, thank you for coming. That's the end of the. We did finish a bit early. Unless David, do you have anything to say? Cool. Thanks for coming. See you next week. We'll cover the more advanced stuff.
We'll be in a different location, so make sure you check out the GitHub repository for the location.
Cool. We'll be around for a little bit more if you have questions.